everyone, in this video we'll dive into the training of an artificial neural network. We'll cover what training a neural network means, discuss loss functions, explore the stochastic gradient descent algorithm, and understand backpropagation. In our previous video we looked at the structure of a neural network and talked about its learnable parameters. To recap, these learnable parameters are the weights and biases which are modified during the training process. If you haven't seen this video, you can find a link to it in the description or on the top right corner. So what does training an artificial neural network involve? Essentially, it's about tuning these learnable parameters to values that improve the model's accuracy in making predictions when new data is fed into it. Training a neural network is an iterative process. With each iteration, data is fed through the network's layers, and the model computes an output for each training example. After computing the output, we then move backwards through the layers and calculate how each learnable parameter influenced the output. Each parameter is then slightly adjusted in the direction that improves the model's predictions accuracy. This process is repeated until the model evolves to produce more accurate predictions. Another way to think about the training of a neural network is that we are trying to solve an optimization problem. What we aim to optimize are the weights and biases within our network. The way in which these learnable parameters are optimized depends on the optimizer we choose for our model. The most widely known optimizer is stochastic gradient descent, or SGD for short. The goal of SGD is to modify these parameters in a way that minimizes a loss function. This loss function measures how well the model's predictions match the actual labels of the training data. By iteratively adjusting these weights and biases, SGD helps the model improve its predictions and reduce the loss. During the training process, each training example has a label attached to it. This label tells our model the correct answer it should have predicted for the data that was fed into its input layer. Let's imagine we're training a model that predicts whether a given email is spam or not. In this case, the training examples will be emails that are labeled either spam or not spam. For each training example, our model will make a prediction on the data by assigning probabilities to the email being spam or not spam. The loss function then calculates the error between the prediction made by our model and the answer written on the label. We'll call this difference the loss. There are different types of loss functions and each of them computes loss differently. For simple binary classification problems like our spam and not spam example, a commonly used loss function is binary cross-entropy loss. After the loss function calculates the loss, it's time to tweak the learnable parameters of the model using the SGD optimizer in a process called backpropagation until the loss is minimized. This is done iteratively as we pass many training examples to our model, and the same training data set is passed through the model several times before it converges to a minimal loss. Now that we have a general understanding of what training a model is, we can move on to explaining stochastic gradient descent and how it works to find the minimal loss for our model during training. As mentioned earlier, with every pass of a training example, the loss function calculates the loss. Once this loss is calculated, SGD aims to minimize it by slightly modifying the learnable parameters in a direction that reduces the loss. Let's look at a single way to see how SGD does this. The first step is to calculate the derivative of the loss with respect to the weight we are trying to modify. This derivative indicates how much this particular weight contributes to the current loss. After finding the gradient value, we multiply it by a small number called the learning rate, which typically ranges between 0.001 and 0.1. We then update the old weight by subtracting this product from it to get the new weight. Recall that during the training process, the same data is passed through the model several times. Each complete pass of the data is called an epoch, and using SGD, our model will gradually converge to a smaller loss over several epochs. Another key algorithm during the training process is backpropagation. While we've seen how SGD works to update a single weight, backpropagation is the method used to update all the weights and biases for our model. In this video, we'll focus on the general understanding of how backpropagation works, and in a later video, we'll dive deeper into the math to get a clearer picture of what it's actually doing. Essentially, backpropagation computes the gradients of the loss function with respect to each weight by using the chain rule of calculus. This allows us to update the weights and biases for our network. We saw that during training, data is first passed forward through the network's layers until it reaches the output layer, where the output is compared to the true label to compute the loss. Using backpropagation, we then compute the gradient of the loss with respect to each weight in the network. This is done layer by layer, starting from the output layer and moving backwards to the input layer. The gradients are computed using the chain rule, which allows us to propagate the error backwards through the network. Once the gradients are computed, we update the weights using the stochastic gradient descent optimizer. Alright, that will be all for this video. Thank you guys for watching, and if you found this video helpful, please like and subscribe to the channel. I'll see you next time.